We first started using Opera in 1992, 2D code. We got Opera actually because we were looking for codes to simulate magnetron plasma systems for coating thin films. And this is very important in these sorts of things. So we were quite excited to get it, and we've been using it since then for magnetron sputtering for thin films, electron beam guns for X-ray tubes and other devices, particle accelerators, and well, just plasma applications in general.
Just going back to the magnetron, what is it that you're trying to show with Opera and trying to simulate? You mentioned about the charged particle tracking. What is it you're trying to
a magnetron has a magnetically confined racetrack. Looks very much just like an oval racetrack, like Indianapolis or something like that. Yeah. When you emit electrons, they will come off, they spiral around magnetic field lines and hop. And so they go like this, and they find their way all the way around the ring. This keeps the electrons very close to what we call the target, which is a material that you bombard with ions. This makes a vapor. That vapor then can condense on a substrate such as a silicon wafer, flat panel display glass, any number of things.
Right, so it's a technique for coating material, effectively.
Yes, and the magnetron is a technique for confining the plasma close to the magnetron. That results in much better property films, right, and much more rapidly deposited films. Okay. And without the magnetron, we would not have, I would say, any of the microelectronics we have today, flat panel displays. It was a very critical invention when it came about. And right, I actually worked with the inventor who held the patent when we first started working on this. It was quite interesting.
And Opera, you use Opera to track the particles and understand the way the particles work and the beam and the deposition?
Yes, well, there's two aspects of using Opera for this. One is the 3D magnetostatics code, which used to be called Tosca. This will simulate the magnetic components in the magnetic field, and it does quite a fantastic job. The materials can be completely nonlinear, they can be anisotropic, and it produces fantastically accurate representation. Once we have that magnetic field, then we use the code 3D space charge, which used to be called Scala, and that will inject electrons and positive ions into the solution along with the electric field, and that in combination with the magnetic field gives you a self-consistent, comprehensive simulation that can include, depending on how long you want to wait for the analysis to finish, a remarkably deep picture of the physics. When it's done right, you get exactly the right answer. The result of this is you can develop a magnetron or an electron beam gun entirely in virtual space with the software. And once it's fit, you can experiment on it, you can optimize the design, you can produce a set of drawings, send them to the shop, they build it, and it actually does work the first time.
So you'd say that the reliability of the simulation from Opera is very good?
It's fantastic. You have to be careful about your inputs, of course. It's
rubbish
the old
in,
garbage in, garbage out.
That's right.
Yes, but given that you put proper information into it, you can't beat it. X-ray tubes are another example. If you design an X-ray tube model properly, you will get exactly what the real thing will do the first time.
If there was one particular standout feature of Opera that you rely on, what is it?
The feature of Opera that we appreciate the most is the comprehensive suite of charged particle physics that you can do. You could emit electrons from a hot wire. Those electrons can collide with a surface, bounce off of it. Those electrons can be tracked. You can see how much heating is caused by that. Electrons colliding with low pressure gas produce ions. All of these things can be looked at all at the same time, and it's that self-consistency in which everything can be included in one model. You don't patch things together at the end. That's really fantastic. It's been nice working with it over the years. It's been nice to watch the software become more sophisticated, more friendly, better graphics, much, much faster.